So, now we're going to tie it all together. So last time we talked about proportions and ratios. Then we talked about how we could solve them in geometric problems using triangles and things like that. And now we're going to use proportions to identify similar polygons. Use proportions to identify similar polygons. So there's two new words here that we have to discuss. The first word is similar. Okay? You have heard that word before. Thing that always takes me back when I remember similar is I remember you're similar to your biological parents, obviously, because they made you. So, similar, right? My grandmother walks up, she shows me a picture. She's like, oh, look at this picture. I'm like, oh, that was me like 5 years ago. Then she walks up even closer and it's like, oh no, that's my father. Okay? It's a scary similarity that you don't realize happens, but it does, right? You're not the same, you are different, but you have similar overlaps, right? So, when we talk about similar, we're going to talk about how some of the corresponding parts of the two figures are similar. Okay? Some of the angles have a relationship and the sides have a relationship. But we also have to talk about this word polygon, which means many sides. So a polygon is any type of closed figure, geometric figure, that has a closed number of sides. Like a triangle has 3 sides, and a quadrilateral has 4 sides, and a pentagon has 5 sides. So when we talk about this thing called a similar polygon, the symbol for similar is very similar to our symbol for congruent. When we had congruent triangles or congruent symbols or congruent figures, what was my symbol for congruent? Equal sign with the squiggly, right? Equal sign with the squiggly on top. Similar is going to be similar. It's just going to be the squiggly. So equal sign is an equal sign. Congruent sign is an equal sign and a similar sign. And similar is just a similar sign. So, what makes two polygons similar? The corresponding angles are congruent. The corresponding angles have to be congruent. However, the sides, the corresponding sides, are proportional. The angles are congruent, but the sides are proportional. So when I look at the corresponding sides of these two triangles, or corresponding angles, I should say. When I look at the corresponding angles, what angle corresponds to the other angle? What does angle A correspond to? X. Angle A would be congruent to angle X, because they are similar figures. Angle B would be congruent to what? Y. And angle C would be congruent to Z. Since all those sides, all those angles are congruent, that's one step towards naming that these two triangles are similar. So I have triangle ABC, and it would be similar to triangle X, Y, Z. See how the order of the letters match the order of my congruent angles? That's very important to recognize. So, which sides would match up? What would AB pair up with? What would AB pair up with? X, Y. So AB would be proportional or have the same ratio as X to Y. What about BC and X and YZ? Sorry, BC and YZ. They would also have the same ratio. And the final pairing of sides, CA or AC, and XY. XZ, sorry. XZ. Everybody see how the ABC triangle is always on top and the XYZ triangle is always on the bottom? Yep. I guess technically you would, yes. Since they're talking about side lengths. Good catch. come out with that? Thanks. All right, so if two triangles or two polygons per se, okay, any type of closed-sided figure, are similar, then their ratio of their side lengths of their two corresponding sides is called a scale factor. It's called a scale factor. So when I look at the pairings of my sides here, if I look at AB and I look at XY, if I look at AB to XY, AB over XY, what's 10 over 5 equal to? 2. So wouldn't that be true for all of my matching sides? What about BC and YZ? What's 14 divided by 7? 2. And what's 12 divided by 6? 2. So as long as they all have the same scale factor, then they're similar to each other. Okay? So, let's use this similarity statement, or maybe a picture if you need to figure out which angles and which sides would be proportional to each other. Go. Fill in the blanks. If you need to, you can always draw a picture, right? I have one polygon. We can call it L, M, and O. And I have another polygon, which is going to follow the same order, H, I, J, K. M is going to pair up with I. They're matching spots. K is going to match up with angle O. Angle N is going to match up with angle J. And obviously L and H go together. But what about the sides? If I look at JK, which side of JK matches on my other figure? NO. Everybody see that relationship that they have? Looking at the similarity statement, couldn't I also do the same thing? HK. Here is H and K on the outside. HK matches with L and O. Okay? So looking at the picture or the similarity statement gets you the same result. HK would also match with LO, and that would be it. Okay? Drawing a picture or looking at the similarity statement, you get the same thing. Alright, last page, let's flip it over. Let's get this done. So here we have two polygons. They look like trapezoids. And we know that they're similar to each other. See the order of the letters here? The order of the letters matters. Those sides and angles have to correspond to each other, meaning the angles are congruent and the sides are proportional. So the first question they ask for is, what's the scale factor of a polygon ABCD to GHIG? ABCD over GHIG. That's the order they want my letters, that top and that bottom. So when I look at the sides that correspond to each other, well, which two sides am I going to pick? Because which two sides do I know?
11 and 5.5.
Specifically AD and GJ, right? Those are the two sides that I know. And when I take 11 and I divide it by 5.5, I end up with 2 over 1. So my ratio is 2 to 1. What's my scale factor for the other way around? How do I know it's the other way around? Well, look at the order of the words. GHIJ to ABCD. Here they want it flipped. So I have to make sure I flip my ratio. So this is going to be equal to 1 over 2, or 1 to 2. Okay? The order of the triangles are in the statement matters. It's 1 over 2 or 2 over 1. But we can use that new scale factor to find my missing values. So here's x, right? They want me to find the value of x. What side corresponds to CD on the other polygon? IJ. So if they're the same corresponding sides, their ratio, x over 8, would have to be equal to what ratio for the two quadrilaterals? X over 8. Big over small. 2 over 1. Why did I put the 2 over 1 rather than 1 over 2? Because x is part of the ABCD triangle, so he's going to be up top. So, what divided by 8? No, 8. What times 2 gives me 8? 4. So x equals 4. What?
Yeah, obviously you did
No,
that.
that's wrong. I fixed it.
I think we should all get
You just don't want to give it any more minutes.
I caught it though, but you guys didn't catch me first. 16. You guys had your chance and you blew it.
this man.
How do I find y?
This man.
Yep, but what goes on top, what goes on the bottom, Brian? Y can go on top, that's fine. You want to put 8 on the bottom? So if he's doing y over 8, what ratio would he use? 1 over 2. If he would have done 8 over y, it'd be 2 over 1.
I think I get a bit for that.
I was just... So now, what would I do? Divide y in half. Divide 8 in half to get y. That'd be 4. I wasn't too far off. It wasn't like I was totally out there. What's the length of HI? It's 5.5 because they're matching sides. Alright, so find the perimeter of each polygon. Go. Find the perimeter. How do I find perimeter? Add them all up. Go. Hey, another way that you'll see perimeter written sometimes is they'll give a capital P and then they'll list the letters A, B, C, D, but they're listed really small. So what's the perimeter of A, B, C, D?
46.
Of A, B, C, D?
Yeah.
46. What's the perimeter of G, H, I, J? 23? Alright, so those are my two perimeters. What would be the ratio of the perimeters of ABCD to GH? If I did this and I divided them in half, what would the ratio be? 2 to 1. Wait, that sounds like the ratio of the sides themselves. Well, that's a new theorem. Okay? So, if I have two polygons that are similar, then the ratio of the perimeters is equal to the ratio of their corresponding side lengths. If two polygons are similar, then the scale factor of their perimeters has the same ratio as their corresponding side lengths. We have one last question to try. Go ahead and use those perimeters and see if you can find their side lengths. The ratio of one side of ABCD and the corresponding side of DEF is 3 to 5. So that means if I would look at triangle ABC, one side, let's say it's AB, is 3. What would the other side of the corresponding triangle be? DEF. Wouldn't it be 5?
Oh.
It's 3 to 5, right? So if those sides are 3 to 5 and they're similar, because they tell me they are, and the perimeter of DEF is 48, how would I find the perimeter of ABC? Remember, if two triangles are similar, their ratio of corresponding sides would be equivalent to the ratio of their perimeters. So what's 3 times 48? 3 times 50 is 150, and if I take away 6 from that, I end up with 144. So 144 is equal to 5x, because we're trying to find this value right here, x. So when I divide by 5, x equals 28.8. That's the perimeter of my other triangle. Thank you. Good catch. What are my units? Inches. Always look through your problem and try to find the right units to match up.